we're solving polynomial equations and inequalities graphically. So when we're doing this, when we're solving an equation, there's actually no y in the equation, unless it's all in terms of y. So different from solving linear and quadratic inequalities from last week, where we had y less than or equal to something in terms of x, that we shaded. Now we're not going to have any y's, except for the fact that we can use our calculator to help us. And our calculator, you have to graph the functions, but we use that to represent an equation. So you just have to be aware of the difference by the end of this. So here's the graph of some function. Looks like it's a cubic, right? 3x intercepts, just passing through each x-intercept, each zero of the function, okay? Use the graph to estimate values, a good estimate, right? But sometimes they're not that, it's a little bit hard to see. So we're looking here at the equation when it's equal to 0. So when y is 0, what's x? The value of x. Well, that would be the x-intercepts. Okay, so the values of x, where the graph of f of x crosses or touches the x-axis. What are those values? X equals, well, that looks like, again, looks like about halfway in between -2 and -3. So -2.5, 1, 4. Or you could say -5/2. Okay, okay. In this case, no, because it says estimate. Okay, so now f of x greater than 0. So you're looking for all the y values that are greater than 0. Okay, and what are the x values that give that? So we talked a little bit about this the other day. So that would be in all of these parts here. Okay. Now, greater than 0 means it's not going to touch, it's not going to include those x-intercepts. Okay. So these are the values of x where the graph of f of x is above the x-axis. So what values? -2.5 to 1. X is anything in between there. And then as well, x is greater than 4. Only thing different between that question and the next one is that this one has an equal sign. Okay, so the values of x where the graph of f of x is above or touches the x-axis. So only thing different would be the equal sign in the inequalities. Then where is f of x less than 0? So where are the y values less than 0? That's everything below the x-axis. So these would be open circles as well. So that's going to do that in green. So here it is below the x-axis. And so what values? Well, that's everything less than -2.5. And then everything between 1 and 4. And then again, the only thing different between that and the next one is the equal sign. so is below or touches the x-axis. You just include the equal signs. Okay, so then it says, it gives us the equation of that graph, and it says use the table feature in your graphing calculator. So let's do that. We haven't talked about the table feature much. I don't use it that much, but it might be good for checking this out. So clear off anything that you have there, and enter that function. You can use, if you have the capability for a fraction, you can use that. So 1 over 5, or 1 divided by 5 is the same thing. Okay, let's, what was the window on this graph here? It went from -4 to +5, basically, -9 to 8. So window, we can just actually just use your standard screen. Okay, now, table feature. So if you look at the top here, there's a table set and a table, okay? If you just go second graph for table, it'll use the x values that were previously used for the last time you may have set it, which you probably haven't, but in any case. So you might see it going up from different numbers than me. Mine are going up by ones, and it gives the corresponding y value. If you cursor up, it'll go more negative. Well, the information here says change the settings to start at -4 and have this delta means change in the table going up by 0.5s. Mine's all going up by ones. So I'm going to go second window, which is table set, and I'm going to go, okay, I'm going to start at -4. Not that that really matters, it'll go all the way to infinity, basically. Enter on that, and I'm going to now change that, though, to 0.5. I think the default setting is going up by ones. Just leave these as they are. And now, if I go to table, you can see it goes up by 0.5s. If I cursor up, it'll go to more negative. So that starting point of -4 doesn't really matter. But now I can see more values. You could go up by 0.1s or whatever. But this is basically a table of values, okay, for your graph. So checking out our answers, if we're looking for where the graph, where y equals 0, then I would be wanting to look down here when y is 0, okay, -2.5. That's one of them. There's another one at 1. There's another one at 4. Just confirms, okay? Then when the graph is greater than 0, that means I want y values that are positive. So I don't want these ones. So I want these ones here. So they are basically between, so less than 1. Oh, sorry. Less than 1 and greater than -2.5. So exactly what we have. So it's just confirming, right? You don't have to use the table feature. It's just another thing in your calculator, though, to know that it's there. It helps you use it. Okay. Okay, so now the graphs of two other functions. So y equals f of x is the solid graph. So it's called f, and g is the dotted graph. Okay, they're just two different graphs. Nothing to do with inequalities from the last two different graphs. So this one here is y equals f of x. This is y equals g of x. So use the graph to estimate the values of x so that f of x equals g of x. So where are the graphs equal? So this is back to systems of equations, the math 10. We looked at where they intersected. So where these two intersect is there, and there, and there. Okay? So that's intersects. The graph. So the solution, so in these, you only want the x values, not the y. So where does it intersect here? At x equals -3. Here is -1. And here is 2. Because remember, if we were to actually, if we knew the equation for f and for g, this would be all in terms of x and all in terms of x. There would be no y's in there. And you're making them equal to each other. Okay, so now, the values of x, where the graph of f of x is greater than the graph of g of x. Okay, so the last one, when f of x was greater than 0, it was above the x-axis, above 0. Well, now we want this to be greater than the other function. So f of x is a solid one. What intervals is it above the dotted? Well, in this interval here, okay, so there it's above. There it's equal, so this doesn't have an equal sign. So you could kind of like, this is just your work, but you could kind of have an open circle. And then where is it above again? Here. All right, so for any of these x values, if you compare the y values, the solid line is above. Here, for any x value, the solid line is above. So the graph of f of x lies above the graph of g of x. So for what x values? So that's between -3 and 1. And then greater than 2. You don't care about the y values. So we are using the graphs to help us. But the graphs are y equals. Now we're making the, comparing them to get our x's. Okay? Obviously here, greater than or equal to lies above or intersects the graph of g of x. So you just include an equal sign. And then less than would be the other intervals, right? So where is the graph of f below? So f is a solid, so that would be here, circle, and then here, and that's it. So that's for x values less than -3. So there. So x is less than -3, and then for x between -1 and +2. Oh, you know what I did here? Did I put +1? Yeah, this should be -1 here. So just put in that. And then from -1, +2. And then lies below, and lies below, or intersects then you just include the equal sign. Okay, so flip over. You're gonna have to flip your book. Okay, so now we're going through the two methods to help you solve equations and inequalities. What do I want to do? Okay, so polynomial equations and inequalities can be solved by graphing corresponding functions. Two methods. So method one is you're graphing the left-hand side and the right-hand side. So that would be like a graph that we just did. It was graphed for you. So you'd have two. The other method that if you look this way, you'll see, is rewriting the equation or inequality. So one side is 0. So that's just rearranging your graph. You're going to decide which you like better, okay? Usually we'll probably end up doing the second method. Well, for sure when you're doing it algebraically, you would do this. Graphically, totally up to you, okay? In any case, here we're asked to solve this equation. Notice, then we're also asked to solve this, which is an inequality, and then this, which is an inequality. They're all the same except for those signs, right? The left side is the same as in all of them, and the right side is the same. So the values of x that satisfy the equation and the inequalities can be found graphically by graphing each of them, so you can see it there. So your left side is x squared minus 4x plus 1. Your right side is x plus 1. Okay, so easiest way, just look at the left side, look at the right, graph each side, there's the graph. Okay, so now label, hopefully you can do that, the linear needs to be the right side, so this is y equals x plus 1. This is y equals x squared minus 4x plus 1. Okay. So use that to estimate the solution, so equal to. That's your point of intersection. Here there's 2, and you want to look at the x values. So x at that point is 0, at that point is 5. Now, for an inequality. No y's there. We're comparing these graphs. So when is the left side, that's the left side, sorry. When is y1 less than y2? So your y, you could even label this. This was your y1, and this is your y2. So when is the parabola below the line? Well, that's between here and here. So there's no equal sign in there, so it's between there and there. I'm just graphing that. That's my work, right? That's not really the solution. The solution is all the x values. But that tells me, oh yeah, that graph is below the linear for all of those x values. And so here, what is that between 0 and 5? Everything between that. Okay. And then back to our first unit on reasoning when we graphed solution sets on a number line. So graph, this is on real numbers, okay? This would be 0, this would be 5, and we want everything in between there. But then an open circle at 0 and 5. and then greater than or equal to. So that would be the other parts. So now the parabola here is above and equal to, so we can include those points. Parabola is above. Okay. So basically it's what are the x values? If you look down to the x-axis, if you shine a light on that green, what x values is it representing? So 0 and 5 still, but we have solid, arrow to the left, solid, arrow to the right. Okay. Then there's a practice question that's given to you there. I'm going to leave that for you to do. Just put a star. You go back and use your calculator to do that one. You don't have to graph that by hand, right? Y1 and Y2. Let's look at the next one. So turn to method 2. A different equation here. And yours says question 5 and mine says question 4. Anyway. It's the same. No, it's different. Okay, it's the same thing. Oh, did I miss something? Oh, yeah. Sorry, practice question is after this. So let's, don't turn over your page yet. We'll go through this one together. Yeah, okay. So question 4, do this graphically. So we're going to take the left side here and call it Y1, and the right side Y2. Get out your calculator and graph those. Okay, I've used a standard screen. So graph it first and see if you need to change your window or not. So notice how I can see that it intersects twice there. Not sure what happens down here. So I'm going to go to my window and I'm going to change my Y min, maybe to, let's say, negative 20. My Y max doesn't have to be as big, so I'm going to go just to 5. Okay. There, you can see. Okay. There's actually 3 points of intersection. Remember, overall, that's a cubic, right? It's degree 3. So having 3 points makes sense, 3 or less. So if you were asked to do this on a test, we're not going to give you grid paper. You're not going to be asked to graph it exactly. We actually, all we want is for you to state Y1 and Y2, which we've already done. Then state your windows. Okay, so when we state windows, we might even give you that. The window here is vertical. We do it horizontal just to save space. Okay, so the 3 values that you're going to put in are your X min, your X max, and your scale. Now, your window might be different from mine. That's okay, as long as you can see those 3 points, right? So if I were to copy what you put into your Y1 and your Y2 with that window, I should see all the important information, where they intersect. That's how I check, because I can't come around to all your calculators and watch you do it, right? But that's how I know. So then here, negative 25, and I just went up by 1. So if you had left it, remember we started with the standard screen and went negative 10 to positive 10. We couldn't see that point of intersection. So you would get half a mark taken off for the wrong window. Okay, because I can't see it. If I replicate what you're doing, I can't see that. So then, in this case, so now we can go back to our graph. We can do a little sketch. Okay, I wrote really big in any case here. So you're gonna have the same colors as them. So here, parabola, and then zigzagging up, something like that. Okay. Those are the points of intersection. So no scale, that's just a sketch. Technically, I think when you get to Math 30 on the diploma exam, they don't even actually need that. They need that, the window, and then a statement of what you're looking for. So this is an inequality. Okay, first of all, you'll notice that it asks you what the solutions are. So in this case, I'm going to reduce this. We are looking for the x values at the points of intersection. Okay, and this is where you would list them. But there they are. We kind of prompted you, but on the test we might not. So what are those x values? So then you get out your calculator and you go second trace intersect. If you just do it right away, enter, 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 it's going to go to the closest one. Again, you don't care about the y, the x is negative 1, so that's one of them. Do it again, second trace intersect. We have to go closer to another one, otherwise it'll keep giving you the same one. Enter, 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 so negative 3. And then a third time, intersect, again, cursor closer, there, enter, 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 and 1. So negative 3, negative 1, 1. So even though it's not an equation, it's an inequality, we do need to know what those points of intersection are. So now, solve that inequality, which means write a statement that represents all the values of x that make that inequality true. So we want this cubic, when is it less than or equal to? So that would be this part here and this part here. Cubic is the blue on mine. Okay, so that's going to be x less than or equal to negative 3, and then everything between negative 1 and positive 1. So that's your solution. You can put it in squiggly brackets if you want. And then on a number line, again, we kind of prompted you, right? Negative 3, negative 1, 1, we've graphed them. Again, they're not measured exactly. It's a sketch. These are your real numbers. Okay, and we are graphing where we include the points. one you're going to do on your own. So now turn over. We'll finish this off today, and then tomorrow, Monday, you'll have a little bit of work time on it, and then we'll get a start on the next day's stuff. Okay, so this is where we get everything to one side. So it says method 1, it is time consuming to determine appropriate window settings. So method 1 is harder with those window settings, because what if you're not sure, does that intersect again somewhere, right? Especially as you get into higher degree. What's nice about this method is you're always looking on the x-axis, because you're going to make one side equal to 0, so you're really looking at where are the x-intercepts. And so then it's really easy to see, is it going to cross again? Okay. So this method's faster. So it says rearrange this. So it's a cubic. I'll leave the x cubed on the left because it's positive. I'll bring this over to there, collect like terms. That's going to be 7x squared. This over, that's going to be minus 20x. This over is dating at minus 96. Okay. Still graph two functions, although technically you don't have to because you do have a feature in your calculator that you can use. But I'll show you this method is a bit faster. Okay, so get out your calculator. Y equals, clear off what you have. X cubed. First you're out of the exponent. Sometimes I forget to do that. Okay. I'm going to go back out, start with a standard screen, and then change it if I need to. Okay. Looks like 3 vertical lines. Right, but if you follow it, it's slowly making that. It's going to be a cubic. Okay. So if you wanted to, you could change your y, but you don't need to. I can see 3 points of intersection here. It's cubic. I'm never going to have more than 3 points of intersection if it's degree 3. Whatever the degree is the maximum number of points of intersection. So I'm not going to do anything to my window, because I know I'm not missing anything. If you thought, maybe you only saw 2 of them, let's say I did a window like this for some reason, negative 10 to 1. Okay, and I know it's a cubic, but I only see 2. So then I want to think, oh yeah, I better go check my window, and then maybe you're not sure where it's going to be. Maybe you make it negative 20 to positive 10. You expand it both ways. And then you see 3. Okay. So the standard worked, but let's say you didn't change it back to standard or something like that. In any case, our window that worked initially was our standard screen. So I'm going to go x-min is negative 10 to 10, 1. Y, negative 10 to 10, 1. Okay. And then when I graph this, so I kind of have there, and there. So even though I can't see that maximum, I'm going to graph it, right? I don't have to change my window. Now, oh yeah, that's fine. So this, even though I can't see all of the maxes, for that y, that's good. right? Because I don't care about what those points are. This is what I'm looking for. And then, of course, if it's an inequality, which it is, then I'm looking for certain parts of it. My other equation was the x-axis. Okay. And then to find those points, I want to go second trace intersect. You can't even see the cursor, but it'll give you the closer one. Okay. I just did a weird little thing on there. Anyway, there's one of them at -3. Okay. Another way, if you didn't graph y2 equals 0, you can use the 0 feature. So if I go to 0, that means on my graph I want to find a point where y is 0. So let's do it for the right-hand one. So I'm going to cursor to the left of where, come on. Okay, left of where I think it is, enter. Cursor to the right, enter. And it's at 4. So that takes more time, and that's why graphing y2 equals 0 helps. Yep. Yeah, as long as you might miss something. Let's say if your x-intercept was a decimal and you didn't have it going to that, right? Then you're going to miss it. So it's not I wouldn't say it's the most efficient way, depending on that. Okay, so that's 4, and then -3 and 4. Another way that I do it looks like it's an exact value. Fast way, that to me looks like 1, 2, 3, 4, 5, 6, 7, 8, -8. So if I am in trace mode, if I'm in trace mode, so I see my cursor, I'm on the function, and I think it's -8. I punch it in, that assumes that the x value, if I enter on that, and I get 0, then I know that's an x-intercept. So if it looks like a nice number, do that. That's the fastest way. Okay, so now, we'll do -8, -3, and 4. So x-intercepts, so that's what we're looking for in this graph. Okay, so now, so we need to go, that's what we're looking for. So -8, -3, and 4. And you could label them on your graph. Okay, so now we want to finish solving this. So this is a less than, it's a greater than 0 function. So I'm going to go to my next page here. So it says compare the graphs of the two graphs that you put into your calculator to solve the inequality where it's greater than 0. We would determine the values of x where the graph is above the x-axis. Okay, so when we look at our graph, so I've got to go back, and we want to look above the x-axis, so that's this part of the graph and this part of the graph, not including the x-intercepts. So from -8 to -3, and then greater than 4. So we want to go -8 to -3, and then greater than 4. Then we graph that, -8, 3, 4. So open circle, join, open circle, beyond. Okay? And then if you want to do the practice question, so here, x cubed minus 4x squared minus x plus 4 less than or equal to 0. Clear off that equation, or your last one, x cubed minus 4x squared minus x plus 4. Oh gosh, let me do that again. X cubed minus 4x squared minus x plus 4. And then graph y equals 0 as well. So we can see all of it. It's a cubic. And let's find our intercepts. Okay, one's at 1. Another method, one looks like it's at -1. Punch that in. It is, because the y value is 0. And then the other method you could use is use the 0 feature. So you want a cursor to the left of where you think there's an x-intercept, and then to the right. Okay, so -1, +1, and 4. So if we were solving the corresponding equation, x would be -1, +1, and 4. But now it's an inequality. So we want to look for the intervals below the x-axis, including on the x-axis. So that's going to be, if we want to graph it on a number line, there's -1, 1, 4. That's not really to scale, but it doesn't have to be. -1, 1, and 4 would be here. So then graphing that, less than or equal to, so it's going to be -1 to the left, and then between 1 and 4. Okay, so then, oh gosh, so then stating that, that would be x less than or equal to -1, then between 1